All right, folks. Happy Friday, everyone. Let me know if my audio's okay. I was literally running around just grabbing things I could use to, like a whiteboard and a Z plus, just to answer some questions for today. How's everyone doing? And let's see. Let me go through the chat while I'm catching up. Um, Hi, Sammy. I am currently drinking a fantastic ginger beer. It's totally only ginger beer. Let's see. Ooh, first question. How often do you find yourself using ER11 collets that are not quarter inch or eighth inch but metric? Not all that often, but that is the topic for, well, the alternate topic for today's chat, which is I've got a bunch of just ER11 collets, really cheap ones from eBay, and I need a way to organize them because like, just this is a mess. So I'm just going to start modeling something to just corral all of them while I wait in between questions and such, assuming it drops off. Um, Unfortunately, no surprise demo for the Nomad 3 today. We hope to have finalized details we can share by the end of this month and availability very soon afterwards. Um, so let's see. Um, Little echoey. Unfortunately, I can't do a lot about this room. It's just you got a window, glass. I could probably get some acoustic paneling for the wall behind the camera right now, but we can improve that in the future. Um, Audio could come up a little bit. Let me bump that up to maybe -4 dB. Um, all right, so let me pull up some questions that I have here, um, and we'll just run through that. And then I will start making my little ER11 collet holder. And then as questions come in, I'll just answer them. If I don't answer it before it just scrolls past the feed, feel free to ask again at the end. I'll make sure I catch any questions we have there. And without further ado, let's get going. So where is my list of questions? I'm using Trello for all of this fantastic organization tool. Highly recommend. So let's see. Where is the episode 17 question list? All right, so first question is wasteboard size on a Shapeoko and how do you attach it to the machine? So I'm going to switch over to the camera view. Let me get that set up. Okay, so whenever you get a stock Shapeoko, you just get bare MDF. You don't normally get this on top of it. This is something you make yourself. You can pick and choose whatever threaded insert pattern you want. We have a file that you can download for free to make a just under 16 by 16 inch, 16 by 14 inch additional wasteboard. We call this the baseboard. Usually it's rarely modified. This would be the wasteboard. This would be any work holding features you add. This is what will get chewed up when you machine. So we have a file that you can download if you'd like. The idea being that you can use one of these for a stock Shapeoko, two of these for an XL, or three of these for a, or, sorry, four of these in a square pattern for a double XL. But again, like it's just MDF holes, threaded inserts if you so choose, or slots where you can put T-tracks into. So you have a lot of options for how to work hold on a machine. It's very open-ended. I recommend that when you're designing something like this, you choose, this is on, but make sure that this width is shorter than the total travel of your gantries, because otherwise you won't be able to surface this and get all the way to the end. So make sure 16 inches or less, maybe something like 15 inches or so. And then in this dimension, make sure you can reach the whole thing. Some of my earlier designs for these, the machine couldn't go all the way back, so you'd have like a little strip of unsurfaced material here. Do not recommend, just because if you're putting a long sheet of stock on here, you want it to sit on the part that you trust to be flat, and that has to extend all the way to the back if your part is overhanging. So about 15 to 16 inches here, about 14 inches here. And then the way that I attach this to my baseboard is I will just place this down where I want it. Sometimes I'll jog this to the middle so I have a fixed reference point so that when I hit the jog to center button in Carbide motion. It sort of lines up with this. I'll take a pencil or a Sharpie marker, or even just go straight to a drill bit, drill through these holes for nominally a 1/4 inch or so, or 6 millimeters if you're metric. Push this aside, and then chase that with either an 8 millimeter drill or a 5/16 drill. And so under here, in my baseboard, I have 4 more threaded inserts that I can screw into. And so this just lets you take this whole thing off if you need to, if you need more room or more clearance. So that is how I set this up. You could also maybe just like use double-sided tape or something, but I find just threaded inserts and screws from the top to be perfectly adequate. Some people might say, oh, but it's only 4 threaded inserts, it's not very strong. When you think about how you're work holding something, sometimes you have 2 or 3 clamps. So if 2 or 3 clamps can hold the vertical force of the router trying to rip the part off this wasteboard, then 4 bolts is more than enough to hold the wasteboard to the baseboard. So that's how I think about that. So, am I planning on making a comparison video between HDZ, Z Plus, and stock Zaxis? We have an overview video for that, but it's not really like comparing like, oh, you can go like this much faster than the HDZ or the Z Plus versus the stock, the old machine. The belt-driven Z-axis is no longer with us. Our base model starts with the Z Plus, so we've sort of just raised the bar a little bit. And we think long-term, it's just better for everyone involved to have a more capable machine to start with. So I don't think we'll do like a, hey, you can go exactly like 50% faster or so on and so forth with regards to the different axes. But one of our questions is, how does the travel on the Z Plus compare to the stock old belt-driven Z-axis? And how does that also compare to the HDZ? So let me switch back to the machine. And so this is the belt Z-axis. I'm using this here just to show people you don't need a super crazy rigid machine to do what we're doing here. You can get by just fine with the machine as it shipped as of, I think, a couple weeks ago. This is a Z Plus. And if you sort of work out the total travel here based on how much rail you see and how much rail you see here, these, even though this is taller, have roughly equal travel. So in terms of how far up and down the router can move, these are basically equivalent. The HDZ will do, I think, 140 millimeters, so it's a little taller, and it will actually move up and down more. In terms of how usable they are versus the HDZ, unless you're using a really long end mill that you need to lift the router up a ton in order to clear your workpiece, about 3.5 inches of travel is perfectly adequate. So really the HDZ is primarily useful for heavier spindles, if you get a VFD spindle or something, because that ball screw is much lower friction. It's got a better ability to carry that weight. So this guy, you can load it to 10 to 15 pounds total. This is about 3 to 4 times stronger than this, just because you've got lead screw versus belts. So that torque amplification of that stepper really helps. So about 45, 50 pounds of just carrying load on this. And then the HDZ will do over 100 pounds just lifting up and down. So that is, if you have that heavy spindle, which can be easily about 10 pounds or so, you'd want the HDZ. So, I have completely messed that up. Okay. Travel, roughly identical. And then HDZ is about another 30-ish millimeters above that. So much taller, more travel, but you're not gonna, unless you have a tool that sticks out like super far, that you need like extra travel in order to clear your workpiece, these should be sufficient. All right. All right, moving on now. Next question. I'm going to race through just everything I have on the agenda for now, and then we can maybe get to some fun stuff if there are no other questions. Okay. How do you get over broken end mills? Well, you sort of just don't. You get better. So what I recommend when you first get started is if you're not sure if you need a specific end mill, like if you're looking at like a down cutting end mill or an 1/8 inch, it's okay to just get something off eBay, get something cheap, figure out if it works for your use case. You can sort of work out your speeds and feeds. And once you're comfortable with that, then you can invest in quality tooling. But start cheap, learn, get good at it, work out your speeds and feeds, and then when you're ready to like hit production mode and knock out a lot of parts fast, then you can really consider investing in quality tooling, find a local vendor or something, and it can be a lot more fruitful to have that support. Also, what I found is that sometimes if you're just ordering onesies, twosies on like Amazon or eBay, that shipping cost will add up. So if you buy from some US manufacturers, you pay for one shipping, you load up on a bunch of tooling, and it can actually be cheaper than like picking different end mills from different people on eBay. Um, so yeah, just start cheap, practice, and then work your way up. But you're never gonna get over that whole like, oh no, I broke an end mill, and there's that like momentary drop in your heart. It it doesn't get better. Um, let's see. Um, what's the improvement to the new HDZs? I don't have one up here. Let me see if I can just pull up for reference an HDZ on the shop. So the changes are really subtle. So if you've got an older version 3.0, 3.3 HDZ, don't feel like you're missing out on a ton. These are just refinements to the HDZ that make it easier for us to assemble them and provide a more consistent experience. So up here, assuming my mouse shows up, we've thrown in dual angular contact bearings that do a much better job of holding the ball screw concentric exactly where we want it. So the alignment with the linear rails is a lot better. And just little tweaks here and there to make a little more clearance for hardware and whatnot, and the switch over to inductive switches. So it's just a refinement of the HDZ that makes it better for all parties involved, and that should be available in about 2 weeks' time. So can we connect a VFD in the board if possible? Technically you can, but it is not officially supported. I'm trying to find on my desktop or my Dropbox. I have a picture of a controller for reference. Dropbox, office hours, reference photos. So on the board, if you zoom in and then go all the way to the right side, there are a couple pins here. PWM is what will give you your spindle speed signal. So if you pipe that into your VFD controller, that's how you can get the automatic RPM control. And then you just need a signal or a relay or a switch to turn the spindle on and off. So yeah, you can also use the PWM, just use that as a signal. It doesn't work as well, but if you look up some of the guides for like how to wire in a laser, you can also see how they do their wiring. We'll see if we can improve this setup in the future for you guys, if you guys say VFD is a feature you want to move to. Let's see, going through the comments. So I understand the new Nomad is top secret at this point, but is it accurate to say new Nomad and the Bantam are aimed at the same market? I'm trying to think of how much I can reveal at the moment. Okay, so the Bantam is going to cost more, and as such, it should be a more, I guess, powerful premium machine. I'll say this, we have a slightly lower wattage on our motor, so they can hit material like aluminum harder, but we're also coming in at hundreds of dollars cheaper than them. And I think in terms of machine balance, we've got a really good value machine, and we've got some secret features we're working in there for you guys. I think each machine will stand on its own end of the market just fine. In terms of like consumer market, like before you go to like a Haas for like a desktop machine, they're similar. But stay tuned. We got some good stuff coming out. Do you have any recommendations on mounting the HTZ on the rails? You ordered a pair of rails, and I don't know how to begin mounting it. So we do have full instructions for installing an HTZ here. If you go to the website, go to the HTZ page, and scroll down, there's a PDF that will walk you through everything. Mainly, it's just there's some V-wheels on the back, eccentric nuts at the bottom. I think it's easier if I just walk you through this. There are 4 V-wheels in the back, and they mount to the rails exactly the same as every other Z-axis. Okay, I like these. More questions are coming in. When is a tool worn out? How long does it take, and how do I know? So if you're doing something like machining wood or plastics, let me pull up some end mills here, and we can just talk through it instead of you looking at my face. So let's see. It's going to be hard to see this, but I'll just talk through this in a general sense. So when an end mill gets dull, you'll notice a lot of just different things when you're machining. So a dull end mill causes more friction as it cuts through material. So with plastic, for example, you might see it might start melting, it might start gumming up the cutter. And if this is a new phenomenon on a new tool, you might want to consider that maybe your speeds and feeds aren't 100% correct. But if you've been cutting plastic or acrylic, polycarbonate, whatever, great for weeks now, and all of a sudden it starts taking a turn for the worst, then maybe that means your tool is getting dull. An end mill in plastic should last months. But if you're cutting aluminum and you start hearing a much worse tone of cut, you might have chipped a flute, or just something is causing the end mill and the router to have to work harder. So that's your first sign that something's gone wrong. In terms of machining wood, plywood, MDF, if you notice burning, scorching on the edges, that means you might have a dull edge. You might have buildup, like there's a lot of tar, pitch, just carbon, sooty deposits that will happen in an end mill's flutes right behind the edge. And for woodworking tools, you can just get some saw blade cleaner or Simply Green, any like basic solvent to clean up that gunk and at least make the edge a little sharper. You can't really resharpen the edge itself, but a lot of the other crud that gets stuck to the end mill will effectively dull that cutting edge. So with wood, clean it with a solvent. With aluminum, sometimes these gold coatings, it's zirconium nitride, will get dull or look a little silvery. That's basically just the aluminum smearing itself against the tool. You can dissolve that using sodium hydroxide or lye. You can find that as drain cleaner in home improvement centers. Just make sure you get the chemically pure stuff, and you just give that a soak in warm lye for maybe 15 minutes. You'll see it bubbling away. That's the lye eating away the aluminum, turning into, I think, aluminum hydroxide, something or other. And then usually you'll see that gold coating just restore back to its pristine state. So you can get a lot of use by rejuvenating end mills that way. But again, if you hear or see or observe something different in how your tool is cutting, that's usually a sign that you might want to just check the tool, make sure something hasn't changed. Usually it's buildup, it's something you can clean off. And if not, just take out a magnifying glass, look at it under a microscope. You'll be able to see if the edge has noticeably dulled or chipped. Okay, moving on. Oh yeah, linear rails on HDZ, that you're kind of on your own for that. There are people who have done it, but it's not something we officially support, so you'll have to turn to the community for that. Okay, tramming spindle. That is actually pretty well aligned with another question we had. So we'll stay on this camera view, make sure that I'm still actually correctly looking at this. Hold on, let me turn this up a tiny bit. Okay, so the question that I had earlier was, what is the difference between tramming a Z Plus and the old belt drive? And so the old belt drive, this spindle mount was held on from the back of this plate with 2 bolts. And so in order to adjust this and shimmy it, you'd actually have to drop this plate down, loosen those screws, wiggle this until you got it a little more level, retighten those screws, check your level. With the HDZ, with the Z Plus, there is a plate that the spindle mount goes onto, and this bolts from the front. So you no longer need to awkwardly get at the screws behind the Z carriage plate. You can just loosen 4 machine screws, shift this to adjust trim in about the Y-axis to get that level, and then to adjust the trim in this axis. My preferred method is to loosen 3 of the 4 screws holding the rails, the X rail on each side, and just pivot the whole thing. Someone commented, if you don't get enough rotation of this to compensate for any unevenness, you could take a small close-fitting drill or a file and just take out some of the powder coating on this. That'll get you like another fraction of a degree of tilt. The other thing you can do is take shim stock or aluminum foil and put it behind either the top or the bottom half of this plate before you screw it back on. And that'll provide you an extra couple degrees head start in terms of adjusting the forward-backward tilt of the spindle mount. Okay, checking that off. How are we doing here in the chat? Let's see. Casey, shoot an email to support. I'm sure Jennifer will get you that. But support@carbide3d.com, and we will try and sort you out. Next question, zeroing on the wasteboard versus the stock. All right, we're going to have to pull out that whiteboard that I mentioned earlier. It's really kind of a, it's nothing too critical, but there's some things I like about one method versus the other, and I'll walk you through why one of them is potentially more useful in some situations versus others. I don't know how well this will hold up. I also don't know if this marker works. That works. If it's too washed out, I will dim the light up there. And I should have gotten a paper towel. All right, so imagine this is your wasteboard, and this is your stock. And this is either an air gap or double-sided tape or something. I'm going to dim the light just a little bit. Where's that? There we go, better. I'll tilt this up more. Stock, adhesive, tape, whatever. And let's say this is your end mill or probe that you're using to reference this. You might be shimmying a piece of paper between your end mill and stock to check when you make contact. So there's a lot of places that you can get error in terms of how you zero. So there's a, this is just a reference, there's a small amount of error that you can get just based on how you're setting this height. When you're jogging down bit by bit, maybe your increment's too big and your end mill's sort of crushed into that stock, in which case your Shapeoko might think that, oh, hey, my zero is down here. Or you, with that thickness of the sheet of paper, you might set your zero up here. So there's a small margin of error when you're setting your zero height, just touching off on your stock. With the bit zero, it's a lot more consistent. It should give you a reading that you can build off of and trust without so much variance, just based on you jogging. And that'll reduce your error, but there still will be a little bit, like if there's some dust or some chips just on the surface, that will shift where your end mill comes to rest. So that's error number one. Error number two is your stock thickness. So you might have 1/2 inch plywood, but it might really be 0.49 inches, 0.51 inches, and it might not be consistent from corner to corner. So there's another little bit of error, plus or minus, that you can introduce based on your stock thickness. And then there's your double-sided tape, or if your wasteboard isn't clean and you put something on top of it, there's chips under it or something, there's a little bit of error introduced there as well. So if you want to cut 100% through your material and that's it, and end right there, you will probably either overshoot or undershoot by a certain margin. And if you overshoot, then you cut into your wasteboard, and you gouge it, no big deal. And so this is the variability that would come into play if you're zeroing off the top of your stock. If you're zeroing off the wasteboard, you have one source of error, and that is just how accurately you touch off and register end mill versus wasteboard. And then you know with much higher certainty that, hey, I will end up in this range, give or take. So if you don't trust your stock thickness to be perfect, but you still want to end up just barely kissing your wasteboard, I found that the most reliable way is to reference the wasteboard and not the top of the stock. So that's just a small philosophical difference in terms of, like, what are you aiming for? Are you aiming, if you're doing a V-carve on the top of your stock, then by all means, reference the top of your stock. But if you're trying to terminate a through cut, a contour cut, right at the wasteboard, or a little bit above to leave an onion skin, I think referencing the wasteboard is the slightly more accurate way to go, and it reduces the variability of the stock and of anything adhesive or just crud underneath your stock. So I know this is probably a little more technical, long-winded than you were hoping for, but that is why I prefer zeroing off the wasteboard most of the time. Okay, how many of you did I lose? All right, looks like no one. So let me take a sip of my beverage. Cutting on a line versus cutting out the whole profile. So this is a Carbide create question. Let's switch to the desktop. Let me get my face off of here. So someone was asking, how do you make sure, or how do you cut only on a line in some cases as opposed to a whole profile? So let's say you're trying to cut something out, but you only want to cut one segment of it. Unfortunately, there's no way to deselect a chain, so the best you'll likely be able to do is to trace on a line. So if you want a 1/4 inch end mill to go on the outside of, let's say, the top of this, you can draw in a line that is offset 1/8 of an inch from that, and then follow that line just to touch one particular wall. Or if you are starting from any vector graphic application, Inkscape or Illustrator, you could create an offset vector by, let's say, 0.125 inches on the outside, and then take this line and then just manually trim away the nodes that you don't want. I don't think we have a way to delete individual nodes here. So yeah, if you create a line that is offset by the radius of your end mill, you can focus a toolpath on a specific spot. If you're just trying to, like, use your CNC as a bandsaw or something and just saw through a board that you have laying across the machine, that's one way to do it. But otherwise, create that line outside of Carbide Create so you have a little more flexibility in where your toolpaths go. And for a trace operation, you would select a contour and then pick the contour toolpath and then pick no offset, and that'll make the end mill follow that line exactly. Um, okay, that is that. Where do I find post-processors? So if you're in Carbide Create, you really don't need to do anything. All your post-processor options are right here under the Edit Post-Processor menu. Either the Shapeoko or the Nomad post-processor will work, or if you're using a different Kerbal-based machine, select Kerbal, or if you're just using any CNC, basic G-code provides the most generic possible G-code out there. So you can give that a shot. If you're using Vectric, their situation's a little hit or miss. They don't have a centralized repository of post-processors, but if you search Carbide 3D post-processor Vectric, one of our users has done an excellent job of sort of tweaking and compiling a post-processor for Vectric. One of these topics will have it, but Neil Ferrari has put out a great post-processor that will accommodate tool changes, and it uses the M6 command and also puts in the, I think, spindle start stop. I'll throw a link in this live stream afterwards. But yeah, so Neil Ferrari, look for one of his posts. He has a GitHub where he's uploaded the latest and greatest post-processor for Vectric that's compatible with all the Carbide Create features. And Vectric themselves will actually link to his post-processor, so it's kind of funny. But if you want to make sure Vectric will work, use one of his post-processors. Vectric also, I think, in the past month, released an update to whatever 11.5 or 9.5, whatever, their latest version. They uploaded an older, less compatible version of the post-processor. It should be fixed by now, but again, if you're having issues in Vectric, check out one of the post-processors that Neil has contributed. If you're using Fusion, the post-processor is built into, I don't think I can export an empty toolpath, but the post-processor is built into Fusion already. If you installed Fusion before December of 2018, the post-processor may be out of date and it doesn't auto-update. So in that case, you can go to the Autodesk post-processor library. I think it's cam.autodesk.com/hsmposts. And then you can search for Carbide 3D and download the latest and greatest post-processor for Fusion 360. So that is how you can acquire or check for the latest post-processor for some of the more common softwares that we see used. Meshcam works just like Carbide Create, so if you're using that, it should be built in. All right, how much force does it take to tighten belts? We covered this before, which is why I am sort of doing this at the end. So let me get this junk out of here. I'm not actually going to run through it this time, but so these belts are held in place with a screw in the front and a little angled bracket here. Let's zoom in on that. So angled bracket screw that pulls the anchor, pulling the belt. When you're, I don't think I have the right Allen key to do it. Anyway, loosen, actually, it's an M5 maybe? Okay, we'll actually just tighten the belts. So when you're tightening this, you have a 10 millimeter M5 screw. Is that M5? That is M5. That pulls on this little clip. So adjust the belt through the anchor just until the point where this screw will catch the threaded insert in this bracket. You can sort of just stretch it taut until this catches. And if this doesn't catch, that means you've got to put in a little more slack into this belt. Um, if this clip anchor touches the end frame, that means there's too much slack. But you want to get this to the point just to where this screw will catch. And then that it's not really 10 millimeters of compression. It's 10 millimeters minus the thickness of this plate, minus the thickness of the bracket. That amount of tension is the perfect amount to put on the belt. So it's not based on like force, it's not based on how tightly you crank down on this screw. It's just that amount of tension that the threads put by pulling it, about 4 millimeters or so. So I'm just trying to get this till where it just barely catches. There's a little too much slack going on there. That's not enough. So it's really just based on plus or minus like 1/2 of the GT2 belt. And I think I'm just slightly overshooting it. If you don't keep downward pressure on this clip, sometimes as you're pulling it, a tooth will slip out and it'll basically just undo your adjustment. So make sure that until this back face is bottomed out against this plate, that you're maintaining downward pressure on where the belt folds over. I regret everything about undoing this belt. And so once that L bracket makes contact with the frame plate, it sort of flattens itself out and applies the downward pressure needed to keep the belt from slipping out and shooting out towards the middle of the machine. All right, I think that is everything I have in terms of questions. And so since we still have a little bit of time, I'm going to start just a quick little project to organize a bunch of ER11 collets. So I'm going to do that, I guess, in Carbide Create, unless there is high demand for a Fusion 360 tutorial school. I'll start here. I'll do it both ways. I'll show you how to get started in Carbide Create, and I'll show you how I would do it in Fusion, and we'll go from there. I think that'll be more entertaining for everyone involved. So, ER11 collet. Let me see. Let me switch to partial camera view. Desktop plus webcam. Transition. Cool. All right. So I need a collet that's not in a wrapper. So you can get ER11 collets in just about any size. It's like a universal standard. So unlike a, where the heck are they? Unlike a router collet, like the Makita or the Carbide compact router collet, which literally only fits like our style routers, DeWalt uses something different. Everyone has a different collet. But the ER collets are kind of standardized. So everyone, I don't know if it'll focus, who uses an ER collet has a very standardized version of a collet. So that makes it easy to have a large compatibility between like a lot of VFD spindles or some other spindles like in the Nomad. Use ER collets, they're great. And they come in lots of different sizes. You can buy aftermarket router collets in 1 millimeter increments, 1/4 inch, 1/8 inch, but they're a lot harder to come by and they cost a little more. So if you have a bunch of ER collets, like for the Nomad, you might need a way to organize these. So I'm just gonna make an array of holes to machine out and insert a bunch of these collets. And yeah, we'll go from there. So start with one of these. I'm going to figure out what diameter I want to use to capture this. So looks like about 11.5 millimeters is the major diameter of this. And then, well, I'm starting with 1/2 inch stock, same as for this. just a little bamboo plywood thing with square holes that I made to hold my end mills. I'll basically be making that for ER collets. And for that, I'm going to switch to metric in here, which I know is kind of sacrilegious for me, but we'll get through it. So job setup, I'm trying to think size-wise, want something about yay big. Looks like about 50 millimeters by 75. I'm making these up as I go because I really don't know metric that well. Not ashamed of it, but I gotta work. 50 millimeters, I actually want to reverse that. 50 by, no, actually I want it wider so I can lay it out more easily. We'll just hit OK to apply that. And then I will switch my stock thickness 1/2 inch, that's fine. I'll set my 0 at the bottom of the stock. And then for my document background, let's check spacing of 5 millimeters. It's probably okay. All right, so I have 12 ER collets, and so I will need 12 holes. Let's see. Radius, so 11.5, that's 5.75. And I'm actually going to overshoot this a tiny bit, just because when you're machining any interior feature, there's going to be a little bit of backlash. Your feature is likely going to come out undersized. So I'm going to overshoot this by 0.1 millimeters on each side, so 5.85 millimeter radius circle. Apply that. Control C to copy this. And I will just arrange these as such. And then I think I can just select all 3 of these. Control C, Control C again, Control C, and I have an array of 12 circles that are evenly spaced. I can actually make this overall a little bit smaller. It looks like I overshot by 50 millimeters. No, 10 millimeters. So with 65 millimeters for this tool holder, I will make a rectangle that encompasses everything. Width 65, apply that, and then pick the corner. See that little node pop up? That means I can drag by that and snap it to the origin. And that is basically a really simple tool holder for ER collets. Toolpath-wise, I'll delete this old toolpath. You'd probably want to start from the inside and work your way out. So with these pockets, I would select everything, go to contour, go to pocket. 1/8 inch tool is fine, but if I pick a tool in the, let's go hardwood library, endmill 102, I'll have some pretty okay speeds and feeds set automatically. So I would probably start, I don't read metric units more than 3 digits, but I assume that's a safe feed rate, safe plunge rate, and it's a 50% step over. And so this will be ER pocketing as the toolpath name. Oh, and max depth will be stock bottom minus about 2 millimeters, so 10.7. And that'll take 20 minutes or so. We can probably speed that up a little, but we'll actually put some real numbers to this in the Fusion side of things. So you'd basically make a pocketing toolpath for the circles, and then you would make a contour toolpath. Oops, I deselected that. We'll reselect those for the ER pocketing toolpath. Pick the outside rectangle, do a contour on the outside, same 1/8 inch end mill, step downs, depth per pass is set to about 0.03 inches, whatever. I'm not actually going to machine this using this set of toolpaths, but that's the gist of how you would make a tool holder, ER collet holder in 1/2 inch stock using Carbide Create. So let me just pull up the simulation to see how this would look. And that's your toolpath. So super easy to do. The only thing you miss out on is that these pockets are straight walled, so they don't match the 8-degree taper on the ER collet. And so that just means when the collet is in the pocket, it can actually just sort of twist a little bit. It's not retained super snugly in a non-tapered pocket like that. So what I would probably do, since I'm kind of obsessive about getting like the perfect fit of tools and collets and stuff and like organizers that I make, is I will make this in Fusion. So let's do that. Let's see how much, how quickly I can do this. So I'm going to brighten up the interface. I like looking at a dark background, and you can set that in display settings under environment. I have a dark sky, let's go to gray room, and that just changes the darkness of the background. Let's see, my face is taking up too much screen real estate, so let's fix that. And yeah, that should be fine. All right, so this is just a blank workspace. I think normally I also just ditch the grid. Where's that? Grid settings, layout grid. Just I hide that until I need it. So I think we determined that we would start with stock. That was 50 by 65 millimeters. So I'm going to start by creating a sketch on the XY plane so that the Z face, which will be perpendicular to where the spindle comes in from in the manufacturing workspace, will be lined up without me having to adjust anything. I'm going to create a center rectangle, snap it to the middle, and go 50 by 65 millimeters. Now look at that, this already defaulted to metric. That's unfortunate. And then finish my sketch. So in Fusion, I like to build things up sort of as I would, I don't use this account too often, but one of the first things I like to do in Fusion is change the pan, zoom, orbit shortcuts to SolidWorks. I personally like middle mouse button to rotate. It just seems a lot more intuitive than any other key combination or holding left, right click, whatever. So middle mouse button rotate is how I like to do this. So I like to build up my stock volume first and then apply features to it just like how I would machine it. So in this case, I would create a rectangle that was 12.7 millimeters thick. And then from that, I would extrude in my pockets. You could, in that very first sketch where you're designing everything, put in circles and then just extrude like empty holes, make this look like a block of Swiss cheese or a 1, 2, 3 block. I like to create the stock first and then put in the features. Really just depends on how you guys like to work. On that top sketch, I am going to, let me reference Carbide, create really quickly. So these are spaced by, 15 millimeters or so. I think 3, 1, 2, 3. 3 grid spaces. And so that is from the center. I'll work it out. I know the center to center point for this circle to this circle is 45, and this circle to this circle is 30. So in Fusion, I'm going to create some reference geometry to help me align my pockets. So I'm going to create a center point rectangle, make it a construction rectangle, start from the middle again, and go 30 by 45. So from there, I can create my first circle. I think we said this was going to be, this is diameter now, so 11.7. And I don't want that to be a construction geometry, so I'll just unselect that before I hit enter or click anywhere else. And that is one circle. And then instead of copying and pasting everything, I can create a rectangular pattern, and then I can pick directions and number of instances. In the X direction, I want 4 of these. I want to space them in increments of -15 millimeters. And in the Y direction, vertical, I want 3 instances spaced again 15 millimeters. So that is the circular hole features that I'm going to make. And then in terms of making these pockets, I'll use the extrude function, select the circles. I could have also just did a linear pattern of 1 hole instead of clicking 12 times. Doesn't matter. You can do it however you want. And then I'm going to add a taper angle of -8 degrees, I think. So these will taper down. We'll go down 11. It'll be a pretty thin floor at the bottom, but we'll go down 11 millimeters. And so now we have a tapered hole that it's not actually going to perfectly capture the ER collet because that nominal diameter that I've measured for the widest part is more than ½ an inch up. So really these pockets are going to be, this is about 13 millimeters from the widest point down to the bottom. So there'll be a little bit of wiggle room. And in fact, since this is tapered, I can just make this a little undersized. So let's change the size of the hole to 10.5 millimeters. So I'll just capture the ER collet on a lower portion of its taper. I'll throw a fillet on the edges. If you sort of just hover in place, you can click through geometry and faces. So if I didn't have that selected and I couldn't quite get this right, if you get in the ballpark of multiple overlapping contours, you can just left click and hold, and then a list of features will come up and you can just find the right one you want if your drawing or model is very cluttered. So I'll pick the outer edges and apply a 5 millimeter fillet. And then you have a model that you can machine out. So in the manufacturing workspace, you would create a setup. And you would basically say, where do I want my 0? In this case, on the top, I prefer bottom left corner. And I don't want any margin outside of the part that Fusion will try and calculate toolpaths for, because I can decide where I want these toolpaths to be myself. I'll work in reverse order, just do easy stuff first. 2D contour around the outside. If your toolpath is on the inside and it's incorrect, hit the little red arrow, it'll flip the direction. And this will use an 1/8 inch endmill. I don't have any tools set up in here. I'll use one of the sample tools, sample milling tools. In inch, I want a milling tool, I want a flat end mill, and please tell me you have something in an 1/8 inch size. We'll use that. I'm going to go back in and edit this tool that's in my file, edit tool, go into the holders tab and just remove the holder. I don't need to see it. It's just too much stuff happening. Contour toolpath will go around. You can do this in multiple step downs. So multiple depths of 1 millimeter is fine. I usually do my cam in inches, so I would probably just copy from Carbide Create what my feeds and speeds would be for this tool. So let's use about 1150 for feed rate. So cutting feed rate, 1150. Everything else should follow. I'm just going to reset these to default, which defaults them to the cutting feed rate. Plunge feed rate, whatever. This isn't a real toolpath, but with multiple depths, you should see multiple step downs, which matches pretty closely what we have in the simulation for Carbide Create. And then to clear out these holes, because they're tapered, I would do a 3D pocket clearing. So pocket clearing under the 3D tab, and I would want that toolpath to knock out anything inside this bounding box. Let's see, still got the 1/8 inch endmill selected. It'll sort of just invent a step over of its own and pocket everything out. And then to finish these holes, I would use either a ball end mill or even the flat end mill would be fine. And I would use a 2D boring operation. So what a bore does is it basically just spirals down to a fixed depth, and this will work on any cylindrical geometry. So it could be a cylinder, it could be a tapped hole, tapered hole. It really doesn't matter. Any circular feature it will work on. So I can select these faces, and you can see that it's spiraling down to the final depth. And I can make that a little finer since I'm not using a ball end mill. I'm just lazy. I'll use one tool. I'll change my pitch, which is the distance between each of these spirals, to like 0.1 millimeters. I'll crank up my feed rate to like triple whatever it is now, like 3,000, and then just let that run. This would probably take a little longer, but it's still faster than switching to a ball end mill. So that's how I would attack a problem like this in Fusion versus Carbide Create, but you get pretty similar results. It's just one of these programs has a much steeper learning curve. So that is basically how I would attack the problem. Based on the time, I don't think I'm going to machine this out, but if you follow along on Instagram, you might see a finished version of this show up in the future. So I think it's time. Any last minute questions from anyone in the chat? Any of you guys have fun CNC projects for this weekend? Let us know, share it, tag it. Could Carbide Create Pro do tapered angles? So, yes and no. You can't arbitrarily set an angle. So let me show you how you would do it in Carbide Create Pro. You'd start with a feature like this. You go into the modeling workspace. You would, just like in Fusion, build up the stock and then subtract material away from it. So I would pick my outer rectangle. I would go to Add Component or Shape, whatever. These names keep changing. I want to uniformly raise about 0.5 millimeter or 1/2 inch of material, so 12.7 millimeters. Apply that, show the 3D preview. You get that. Call it a day. And then I'll hide the 3D. The next thing you'd want to do is you'd want to cut away some material for the pocket. And if you do that using the angled shape parameter, actually you can set a specific angle. So you could set 82 degrees, I think, for an 8-degree thing, and you would limit the height, the depth of this pocket to, let's say, 10 millimeters. And then this would be subtracted. Let's apply that, show the 3D cutout. You would get a hole just like that. You wouldn't get the fancy boring toolpath to finish. You'd have to use a ball end mill to get this looking pretty nice, because otherwise you're just going to get sort of waterline finishing marks as the square end mill steps down. But that is how you could create a tapered pocket using Carbide Create Pro. Great question. Joshua's doing a swole Pikachu this weekend. That sounds fantastic. Share that for sure. All right. Well, we will stick around in the chat for a couple more minutes. We'll just close out the live stream. I'll do maybe some preliminary preparation on the Shapeoko. But thank you all for joining us. We'll answer any last minute questions if you didn't catch us. And we'll be back in about 2 weeks, maybe with some Nomad details. I can't say for sure, but hopefully we'll have more to share this month. So thank you all for joining us, and take care. Have a good weekend. And let's see, hold on. Where's the waiting room? And I need to set this up. There we go. Goodbye.